Hello viewers, welcome to Auntie IJ's chemistry class. In this channel, I'll be helping you out with problems in chemistry. Today, we'll be learning another wonderful topic. Today, we are going to look at another interesting area in chemistry, the mole concept. The mole concept. So when we talk about the mole, we are talking about the quantity, the basic quantity for measurement in chemistry. The mole is the basic quantity for measurement in chemistry, measurement of particles in chemistry. And these particles could be atoms, ions, molecules, or even elements. So the mole is defined as the amount of substance that contains as many specified entities or particles as there are carbon atoms in 12 grams of carbon-12 isotope. That's the definition of the mole. Now, like I said earlier, the particles or the specified entities could be atoms, it could be ions, it could be molecules, it could be electrons. Now let's look at the mole and the mass of elements. But before we talk about that, I want to state that this mole concept is always kind of misunderstood by most students. They don't really understand how to handle problems that involve the mole concept. So mole concept runs through practical and the theoretical aspect of chemistry. It's all about calculations. So let's look at mole and the mass of elements. Mole and mass of elements. Remember we said the mole could be used to determine the quantity of atoms, ions, molecules, or electrons. Now, if we are to look at this mole and the mass of elements, now we have that the number of mole, if you are determining number of moles, we have it that the number of moles is given as mass of elements divided by relative atomic mass of that element. So if you are to determine the number of moles in a given mass of an element, you divide it by the relative atomic mass of that element. Let's take a problem. Number 1. How many moles of magnesium atoms are present in 0.80 gram of magnesium? Now, using our formula, number of moles equals to mass of magnesium divided by relative atomic mass of magnesium divided by relative atomic mass of magnesium. So how do we do it? We now say 0.80 divided by 24, and that will give us 0.03 moles or 0.033 moles. Let's look at the second problem here. What is the mass in grams of 0.50 moles of oxygen? what is the mass in grams of 0.50 moles of oxygen. So here we are expected to find the mass given the number of moles. So we go by our equation, formula, number of moles equals to mass of oxygen divided by relative atomic mass of oxygen. So we're asked to find the mass in grams. So how do we do it? We now say mass of oxygen is equal to number of moles multiplied by relative atomic mass of oxygen. And we have been given the relative atomic mass of oxygen as 16. So what is the number of moles? Here we have 0.50 times 16. And that will give us 8.0 gram. 8 grams. Now remember that the mass of oxygen we were asked to find the mass of oxygen here, and we have been given the relative atomic mass of oxygen in brackets here. That's the information given to us with which we can solve, and we have been given the number of moles, which is 0.5 moles. So going by our formula that number of moles, if we are to determine number of moles for elements, we now have to do mass of oxygen divided by relative atomic mass of oxygen, because oxygen is now an element we are talking about. So here the mass of oxygen is given by, we cross multiply number of moles of oxygen which we have been given, multiplied by relative atomic mass of oxygen, and that is 0.50 times 16. That gives us 8.0 gram. So from the explanations earlier made, we now find out that the mass of 1 mole of an element is equivalent to the relative atomic mass of that element in grams. Mass of 1 mole of an element, which we can interpret as molar mass of that element, is giving us the relative atomic mass of that element in grams, is equivalent to that. So if we are to interpret this, it tells us that 1 mole of sodium atom has a mass of 23.0 gram. Then 1 mole of magnesium atom has a mass of 24.0 gram. 1 mole of sulfur atom has a mass of 32.0 gram. And then 1 mole of oxygen atom has a mass of 16.0 gram, and so on and so forth. When you equate the 1 mole of an element to its relative atomic mass. Thank you for watching. Don't forget to subscribe to this channel so that you get subsequent videos. If you have questions, please drop your questions in the comment section.